Scientists are trained to question every conclusion, every graph, every statistic, every assumption. But today, Dr. Michael Foster isn't questioning his research. He's questioning himself. Did I miss the paper that changes everything? It's a dangerous question. Not because he doesn't know how to search for scientific literature, because no matter how many papers he reads, there's always another search term, another database, another study he could have missed. Tomorrow afternoon, his research team will decide the direction of their next experiment, and Michael is responsible for presenting the latest evidence on one simple question. Can intermittent fasting improve insulin sensitivity in adults with pre-diabetes? If his literature review is incomplete, the team could spend weeks discussing an idea that's already been answered, or overlook evidence that points them somewhere better. He spent 3 days searching, yet he still isn't confident he's found what matters most. What happens over the next few hours doesn't make Michael a better scientist. It simply changes how he spends his time being one. But before we begin, you are watching Everyday AI, where we show how ordinary people can use powerful AI tools to save time, work smarter, and solve frustrating everyday problems. No hype, no confusing tech talk, just practical AI that actually helps. Like most researchers, Michael's day doesn't begin in the laboratory. It begins in front of a search bar. Coffee sits untouched beside his keyboard as he opens PubMed. He types a few familiar keywords. Search. Hundreds of results. Then he adjusts one word. Search again. Now the list looks completely different. A few minutes later, he's in Google Scholar. Different ranking, different papers, different authors. He leans back in his chair. If every search gives me a different answer, how do I know which papers deserve my attention? That isn't a question about intelligence. It's a question about time. No researcher can read everything. The real challenge is deciding what deserves to be read first. Today, you're going to follow Michael through a normal workday as he tries something different. Not because he's looking for AI to think for him, he's looking for a faster way to find evidence worth thinking about. But first, he must solve the problem every researcher knows too well: finding the right papers in the first place. By 10 o'clock, Michael has 20 browser tabs open. Some papers look promising. Others only mention intermittent fasting in passing. One investigates healthy adults. Another focuses on patients already diagnosed with type 2 diabetes. Useful studies, but just not for today's question. The frustrating part isn't that he can't find research. It's that every search feels slightly different. Each new keyword uncovers papers the previous search never showed. After nearly an hour, he isn't reading anymore. He's comparing search results. Then he remembers a conversation with a colleague. Stop searching with keywords. Try searching with your research question. Curious, he opens Elicit. The homepage is refreshingly simple. No complicated filters, no long forms, just a search box. He types, "How does intermittent fasting affect insulin sensitivity in adults with prediabetes?" He presses enter. Within a few seconds, Elicit returns an answer. Each result includes citation with title, publication details, and a short AI-generated summary explaining the study's main focus. Instead of opening PDFs immediately, Michael reads the summaries first. The first paper studies healthy adults. He skips it. The second investigates people with type 2 diabetes. Also not the right population. The third catches her attention. A randomized controlled trial involving adults with pre-diabetes. Exactly what he's looking for. But before opening it, Michael notices something. His question could be even more specific. He clicks back into the search bar and edits it. Randomized controlled trials on intermittent fasting and insulin sensitivity in adults with pre-diabetes. The results refresh. Several broad studies disappear. More directly relevant papers move to the top. Michael smiles, not because Elicit magically found the answer, because refining the question produced better evidence. The AI didn't replace scientific thinking, it rewarded it. He opens the first shortlisted paper. Before reading the abstract, he compares it with Elicit's summary. The summary accurately reflects the paper's main finding. After half an hour, something has changed. He hasn't read fewer papers. He's stopped wasting time on the wrong ones. His 20 tabs become 7 carefully chosen studies that genuinely match his research question. For the first time today, Michael isn't wondering where to search next. He's wondering which of these 7 papers deserves his attention first. And that question is far more interesting. 7 papers. That sounds manageable. Until Michael remembers what comes next. Each paper could take 30 minutes or longer to read carefully. The clock isn't his biggest problem. His attention is. He doesn't need to read everything. He opens the first paper. The title is almost identical to his research question. Promising. But halfway through the abstract, he realizes the researchers measured fasting glucose, not insulin sensitivity. He closes the paper. 8 minutes gone. The next paper looks even better, until he notices the participants already have type 2 diabetes. Useful research, but wrong population. He's still spending more time deciding what to read than actually learning from the research. Instead of opening another PDF, he goes back to Elicit's results. This time, he slows down. Not to search for more papers, but to understand the ones he already has. He begins reading the AI summaries one by one, not as final answers, but as a first filter. The first summary immediately confirms the study focuses on pre-diabetes. He removes it from today's shortlist. The second confirms the wrong patient group, another one off the list. Then he reaches a study that checks every box. Adults with pre-diabetes, randomized controlled trial. Insulin sensitivity measured as the primary outcome. This one deserves his time. But Michael doesn't stop there. He opens the original abstract, if the summary is accurate. Only then does he mark the paper as essential. He repeats the same process with the remaining studies. Within 20 minutes, his shortlist becomes even stronger. Now only 5 papers remain. 5 papers he genuinely needs to understand. Not because an AI chose them, because the AI helped him eliminate the ones that clearly didn't fit. Just as Michael starts feeling confident, one summary makes him pause. Unlike the others, it doesn't report positive results. Instead, it suggests the intervention showed no significant improvement compared with the control group. That wasn't what he expected. Every other paper pointed in the opposite direction. For a second, he wonders if he should leave it out. It would certainly make tomorrow's presentation simpler. Then he catches himself. Science isn't about finding evidence that agrees with you. It's about understanding all the evidence. He clicks the paper. Because if this study is reliable, his conclusion may need to change. The paper is well written, detailed, and nearly 15 pages long. Michael starts reading, but somewhere in these pages is the reason this study reached a different conclusion. He could spend the next half hour searching for it. Or he could ask a much better question. He returns to Elicit and opens the paper's chat. Rather than asking something broad like, "Does intermittent fasting work?" he asks exactly what he's trying to understand. How was insulin sensitivity measured in this study? A few seconds later, Elicit summarizes the answer and points to the relevant section of the paper. Michael clicks the source. The original passage opens immediately. He reads it himself. The answer is accurate. Now he asks another question. Why did this study find no significant improvement? Again, Elicit provides an answer based on the paper and links back to the supporting text. This time, Michael notices something he hadn't considered. The intervention lasted only 2 weeks. Most of the other studies he selected followed participants for much longer. Suddenly, the contradiction isn't as mysterious. The studies aren't necessarily disagreeing, they're investigating different circumstances. That doesn't make the negative study less valuable. If anything, it makes it more important, because it adds context. Michael repeats the same process with his remaining papers. Not asking for conclusions, asking for facts. What population was included? What was the primary outcome? What limitation did the authors report? Every answer sends him back to the original paper. Every important claim gets verified before he writes a single note. Slowly, something changes. He's no longer trying to memorize dozens of details. He's building an understanding of how the evidence fits together. An hour earlier, he was overwhelmed by search results. Now he has something much more useful: 5 carefully chosen papers. A clear understanding of what each contributes, and one important study that challenges the rest. He closes his notebook for a moment. Tomorrow's discussion won't be about whether intermittent fasting works. It will be about why different studies reach different conclusions. And that's a much more interesting conversation. The next afternoon, Michael walks into the lab meeting. Around the table, his colleagues settle into their seats. His supervisor smiles. So, what does the evidence tell us? A day ago, that question would have made Michael nervous. Not because he didn't know the science, because he wasn't sure he had found enough of it. Now, he begins with confidence. We found several randomized controlled trials on intermittent fasting in adults with prediabetes. He explains the study that found no significant improvement. Instead of dismissing it as an outlier, he walks the team through its design. Instead of debating whether intermittent fasting works, the conversation shifts towards something far more useful. Under what conditions does it appear to work best? That's the kind of discussion good research is supposed to create. The search bar that overwhelmed him yesterday is still there. The thousands of public papers are still there. Science hasn't become simpler overnight. There will always be another paper, another experiment, another unanswered question. But today he learned something important. The biggest challenge in research isn't reading faster. It's deciding where your attention creates the most value. And that's exactly where tools like Elicit can help. Not by replacing scientific thinking, but by giving scientists more time to do it. If you're a researcher, graduate student, or anyone who regularly works with scientific literature, the free version of Elicit is worth exploring. It won't replace critical thinking, it won't replace careful reading, and it certainly won't replace your expertise. But it can make the first, and often most frustrating, part of the research process much more efficient. If you'd like to try the exact workflow Michael used in this video, you'll find the link to Elicit in the description below. And if there's another AI tool you'd like to see tested in a real-world workflow, let me know in the comments. Thanks for watching, and I'll see you in the next one.